Hi, my name is Patrick Reagan. Part 7, Introduction to TCP IP Model, introduces the TCP IP protocol suite and model and shows how it relates to the OSI model. The TCP IP model is a more practical model that relates to the protocols used on today's modern networks, including the Internet. The TCP IP model and the OSI model are both conceptual frameworks used for understanding and implementing network protocols. However, they differ in their structure, number of layers, and scope. The OSI model is a theoretical model that is more descriptive and detailed, which is used as a guide for understanding network interactions. The TCP/IP model is a more practical model that is closely tied to real-world protocols and implementations, particularly those used on the Internet. The TCP/IP model is a concise version of the OSI model that is more related to the real-world networking. It contains 4 layers, unlike the 7 layers in the OSI model. When looking at a network packet, you can see the 4 layers. TCP/IP stands for Transmission Control Protocol, Internet Protocol. It is a suite of communication protocols used to interconnect network devices, and it's the same protocol used with the Internet. It is the most common set of communication protocols used in private computer networks, including those used in your home and in corporate offices. TCP/IP Protocol Suite is the de facto protocol used with the Internet, home, and corporate networks. With the TCP/IP Protocol Suite, TCP/IP does not worry about how the host, computers, or other network connections connect to the network. Instead, TCP/IP was designed to operate over nearly any underlying local or wide area network, which maps to the OSI model, data link, and physical layers in the DoD network access layer. The network access layer in the TCP/IP model, sometimes referred to as the link layer or data link layer, is responsible for the physical transmission of data over network hardware and for managing the interactions between hardware and software to ensure successful data delivery within a local area network segment. This layer encompasses the functionality of both the data link layer and the physical layer in the OSI model. It is responsible for data framing, physical addressing, error detection and handling during the physical transmission of data, and access control. It includes Ethernet, Wi-Fi IEEE 802.11, Point-to-Point Protocol or PPP, and Media Access Control or MAC. The network access layer is considered a hardware dependent because they directly interact with the physical network components like cables, connectors, and network interface cards, defining how raw data is transmitted as electrical signals over the medium. Therefore, the upper layers, which include the TCP/IP protocol suite, does not worry about how the hosts connect to the network. While the upper layers, Internet, host-to-host, and process and application, deal with logical functions and data manipulation, making them independent of the specific hardware used to transmit the data. The Internet layer in the TCP/IP model is responsible for logical addressing, routing, and packet forwarding. It corresponds to the network layer, layer 3, in the OSI model. This layer ensures that data packets can travel from the source to the destination across multiple networks and can be routed efficiently through intermediate devices like routers. It is also responsible for fragmentation and reassembly. Fragmentation is the process of dividing an IP packet into smaller pieces at the network layer when it's too large to fit on a network path or exceeds the maximum transmission unit or MTU of a network path. It includes the Internet Protocol IP, Internet Control Message Protocol or ICMP, Address Resolution Protocol or ARP, Internet Group Management Protocols used with multicasting, and various routing protocols. The host-to-host layer in the TCP/IP model, also known as the transport layer, is responsible for ensuring reliable communication between hosts on a network. It provides an end-to-end communication services for applications and handles error correction, flow control, and data segmentation and reassembly. With a large file, the TCP/IP layer would further divide the file into smaller segments. TCP reassembly uses sequence numbers and checksums of the segments to reorder them and detect any missing or corrupted segments. The host-to-host is also responsible for multiplexing, which allows you to multiple network applications on the host. It includes Transmission Control Protocol, or TCP, and User Datagram Protocol, or UDP. The process application layer in the TCP/IP model is the top layer that combines the functions of the OSI model's session, presentation, and application layers. This layer is responsible for interfacing with end-user applications and providing network services directly to the user software. It handles high-level protocols and ensures that data is presented in a usable format to the applications. The process application layer includes network services, data representation, and session management. Some key protocols include Hypertext Transfer Protocol, or HTTP, File Transfer Protocol, or FTP, Simple Mail Transfer Protocol, or SMTP, Domain Name System, or DNS, Simple Network Management Protocol, or SNMP, Telnet, Secure Shell, or SSH, Post Office Protocol, or POP3, and Internet Message Access Protocol, or IMAP. As you look at a data packet, you can see the four layers which follows the TCP/IP model. Ethernet is the network access layer. Internet Protocol is the internet layer. User Datagram Protocol is the host-to-host layer. Data is the process application layer. The green box has the destination and source MAC addresses, which is the physical addresses. It also specifies that it is an IP version 4 packet. The blue box has the destination and source IP address, and it specifies that it is a UDP packet. You can see in the red box that the source port is 443 and the destination port is 54864, which is HTTPS packet. The purple box would be the HTTPS data payload. Question: how many layers does the TCP/IP model use? Answer: 4. Question: what TCP/IP model layer corresponds to the OSI model network layer? Answer: Internet layer. Question: true or false? The TCP/IP model does not care about what hardware you use to connect to the network. Answer: true. For more information, visit these sites. In summary, the TCP/IP model and the OSI model are both conceptual frameworks used for understanding and implementing network protocols. The TCP/IP model is a concise version of the OSI model that is more related to the real-world networking. It contains 4 layers. TCP/IP stands for Transmission Control Protocol, Internet Protocol. TCP/IP Protocol Suite is a suite of communication protocols used to interconnect network devices. The network access layer in the TCP/IP model, sometimes referred to as the link layer or data link layer, is responsible for the physical transmission of data over network hardware. The TCP/IP upper layers does not worry about how the host connects to the network. The internet layer in the TCP/IP model is responsible for logical addressing, routing, and packet forwarding. The host-to-host layer in the TCP/IP model, also known as the transport layer, is responsible for ensuring reliable communication between hosts on a network. The process application layer includes network services, data representation, and session management. As you look at the data packet, you can see the 4 layers, which follows the TCP/IP model. Thank you for watching this video. The next series will be basic networking hardware. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.